All right, so we're going to continue energy today. And in this, we're going to do some review of our chemistry unit that was the first half of this course. So thermal energy is heat, and it is described as the transfer of energy between molecules within a system. It is the total energy of particles that make up a material. It is going to include both kinetic and potential energy. All right, so when we talk about the temperature of something, we're talking about the average kinetic energy. Now, if you remember, particles are constantly moving. Solids move slower than liquids, which move slower than gases. Gases are our faster moving particles. All right, and when we talk about temperature, we are talking about the average kinetic energy of that substance within the system. And we are going to measure it in the sciences in degrees Celsius, not in Fahrenheit. I know that here in the United States, we measure things in Fahrenheit. All right, the rest of the world uses degrees Celsius, so scientists have gotten on board with degrees Celsius as well. That way, they can understand all kinds of different projects that other scientists are doing as well. Okay, so if I increase heat, that means I'm going to increase the speed at which particles are moving. So faster moving particles are going to have an increase in kinetic energy. Heat will be absorbed in this process. Temperature may or may not increase. A decrease in heat means we are going to see slower moving particles. Heat will be released, but the temperature may or may not decrease. And now we've already looked at this example, all right, and this information in terms of heating and cooling curves. So over to the right, I have a heating curve. What I'd like for you to do, I'd like for you to pause this video, and I would like for you to fill in this heating curve as we have already learned how to do. Then unpause the video and check your work. All right, on our heating curve, we'll see we have our temperature as the y-axis. Our heat energy is the x-axis. If you remember, A is a solid, C was our liquid, and F, the line F, is our gases. So we go from a solid to a liquid, and when I heat something and go from a solid to a liquid, I say that is melting. And when I go from a liquid to a gas, we call that vaporization. And now if you will remember, our kinetic energy is the average, or I'm sorry, our temperature is the average kinetic energy. So over here, my solids, my temperature is increasing. So we say that solids have kinetic energy. And the same thing with my liquids. My liquid temperature is increasing, so they have kinetic energy. And the same thing with my gases. My gases are increasing, so again, they have kinetic energy. When I melt, at this point, I am all solid. At this point, I am all liquid. In the center, I am some solid and some liquid. So I have some particles that are all solid, where they are very close together. And I have some particles which are further apart. So we say that melting has potential energy because potential energy, we learned in a previous lesson, is related to the spacing of the particles. So as I increase the spacing of the particles, I'm increasing that potential energy. Same thing up here. At this point, I am all liquid, and at this point, I am all gas. So I have liquid and gas together at some point. So at the point of vaporization, I have liquids, which are a little further apart, and I have some gases, which particles are super far apart. So again, potential energy, I am changing the spacing of the particles. Now, Over here, we said temperature may or may not increase in a heating curve. So when we look at this heating curve, at what 2 points does temperature not change? Melting has the same temperature, and vaporization has the same temperature. However, melting does have an increase in heat energy, and vaporization also has an increase in heat energy. If we were to reverse this in a cooling curve, everything stays the same, except we see a decrease in heat energy as we go from a gas to a liquid, and we call that condensation. I see a decrease when I go from a liquid to a solid, and we call that freezing. So this can be expanded upon in terms of thermal expansion. All right, so thermal expansion is when molecules move faster. It also allows them to become further apart as temperature increases. So when I increase temperature, I increase their kinetic energy. They're moving faster, but they also are moving further apart, which we see here in our vaporization and our melting. Okay, so we see that being proved up here in our heating curve. So warming an object causes molecules to speed up or expand. And if you've ever gotten into your car on a cool day and the car, maybe it has a sensor on it that tells you tire pressure, and it says tire pressure is low. And so as you're driving to the gas station to get some air in your tires, the sensor goes off. Why is that? As those tires are moving, it's causing the air inside to warm up. The temperature increases, the air moves faster, they expand, and so the tire actually expands enough that your air pressure sensor goes off. Now, if your air pressure sensor goes off, you still probably need to add some air, even though it went off, okay? Because you want to check your manufacturer on the tires, because each tire is different, and make sure that you keep enough air in it according to whatever your tire is specified for. Thermal contraction is the opposite. Molecules are going to move slower and are closer together as temperature decreases. So this would be what your tires are at the beginning before you get in your car on that cool day. All right, it's cool outside, so the temperature has decreased, causing the air in your tires to move slower. They're closer together, and that's what sets off that alarm telling you to get more air. Okay, so cooling an object is going to cause those molecules to slow down or contract. One additional thing about thermal energy, and that is specific heat. Specific heat is the amount of energy or heat needed in order to raise the temperature of 1 gram of substance by a single degree Celsius. When I go from a solid to a liquid to a gas, energy is being absorbed. All right, and if we look here, heat energy from a solid to a liquid to a gas, it is increasing, meaning being absorbed. And when I go in the opposite direction, energy is being released.